Okay, just two more quick subjects and you are done with the video lectures for this course. So, it's also highly desirable to measure carbon dioxide in breath. So if you're looking at someone that's intensive care, you want to make sure they're oxygenating themselves and they're breathing appropriately. Also during an anesthesia as well, when you're under deep anesthesia. One way you could do this is you could have a 4.25 micron IR laser that could basically look at that absorption peak, because there's a strong absorption peak for carbon dioxide at this wavelength. But that's kind of complicated. It could be a simpler way. Well, you can measure things with change in color, and let's look at them optically and just visually by looking at the fact that carbon dioxide, when it comes into water, it breaks it down into carbonic acid, so it makes the water more acidic. And then you could use something like a color-changing pH strip to basically, determine how much carbon dioxide there is. And so if you look at all these pH indicators, there's all these different dyes you can find which change color based on the pH. So low pH to high pH, they change these colors, and that's how you make pH strips. One example is Thymol Blue. It's a brownish, greenish, or reddish-brown crystalline powder that's used as a pH indicator. So here's some vials of Thymol Blue, and they either added some acid or base. In this case, it's basic. It looks blue. Here's neutral, and here's acidic. And there's a product out there which is used to measure especially respiration for premature babies here, where it basically will change color when they're inhaling versus exhaling. So here we're exhaling and here we're inhaling. So do you think this uses Thymol Blue? Let's try to figure it out. Okay? And again, you can see there they talk about the color change and what that means in terms of the carbon dioxide concentrations. You see they label that out here. Well, if it becomes acidic when there's lots of carbon dioxide and it looks more reddish or orangish, then when I exhale I would have more carbon dioxide. So there we go, we're exhaling. That makes sense. And when I inhale, it's going to look more bluish. And there you go, you're inhaling, you're bringing more oxygen, less acid. So maybe this could be based on Thymol Blue. Not sure, but that's just a guess. And if you want to do really precise pH measurement optically, you do a spectrometer. And like we did for blood oxygen level, you look at the isobasic point where something would change color based on the acid form versus the basic form. This is the wavelength of the absorption. And you do the same things we did before with multiple wavelengths, and you can get a precise calculation of pH using a spectra instead. And if you're real fancy, you can create even simple smartphone apps, like this is work that Dr. Popowski's group here at UC did, where they created a smartphone app that simply takes a picture of a pH strip that's put on top of this reference. And the beauty of this is you put the strip on here, the smartphone basically maps out the colors that it observes with the pH, and then it can tell you the pH based on the colors. And the beauty of this is that there's some printed colors on here which automatically correct the system for the lighting in the room. So if the lighting in the room was more yellowish or bluish, it wouldn't screw up the measurement because it auto-corrects based on these calibration standards. Well, that's it. Nice job. There's just a few more weeks from a longer break, be it most likely for this course it's winter break. It's not summer break, but it's not all that different. So anyway, I look forward to doing the design labs with you at the end of the class, because this is where you get to basically show your stuff and be creative and use all the principles we've learned up to this point. I'm sure some of you will also do some bio-related type final labs as well.